Here we have to integrate x raised to x 1 plus log x. Basically, if you remember, differentiation of x raised to x is x raised to x 1 plus log x. So we can say integration of x raised to x 1 plus log x will be simply x raised to x plus c, which is given in option C. So tada! This is your final answer. In this question, we have to integrate 2x tan inverse of x square upon 1 plus x raised to 4. If you see carefully, we have the differentiation of tan inverse x square. So let's assume tan inverse of x square is equal to t. If we differentiate both the side, on right hand side we have to consider box around the x square. So differentiation of tan inverse box is 1 upon 1 plus box square into d by dx of box. Within the box we have x square, so we just have to multiply differentiation of x square, which is 2x dot dx will become your dt. So if we modify our integration, we will get this tan inverse x square is equal to t, and rest of the term will become simply dt. So integration of t will be t square by 2 plus c. If we substitute the value of t, we will get tan inverse of x square the whole square upon 2 plus c, which is given in option B. Ta-da! In this question, we have to integrate 1 upon 1 plus e raised to x into 1 plus e raised to minus x. So, to simplify our denominator, we have to simplify 1 plus e raised to minus x. It is basically 1 plus 1 upon e raised to x. So, if we take LCM, we have to multiply e raised to x with 1, which will give us e raised to x plus 1 whole divided by e raised to x dot dx. Now, this e raised to x is basically denominator of the denominator, so it will move in numerator. So here we'll get e raised to x upon 1 plus e raised to x into 1 plus e raised to x. So it will be e raised to x upon 1 plus e raised to x the whole square. Basically, here we get 1 plus e raised to whole raised to minus 2 into e raised to x dot dx, which is in the form of fx whole raised to minus 2 into f dash x form, which can be integrated as fx whole raised to minus 2 plus 1, or we can say minus 1 upon minus 1 plus c. So here we'll get 1 plus e raised to x whole raised to minus 1 upon minus 1 plus c, which can be simplified as minus 1 upon 1 plus e raised to x plus c, which is your final answer given in option A. Ta-da! ગજબ લેવલનો સમજ્યા. આમાં ના આવડ્યું હોય તો જરાય શરમ અનુભવવા જેવું નહીં, બહુ જ હાર્ડ સમજે. જો આમાં એક કન્સેપ્ટ યાદ રાખવાનો છે, અંડર રૂટની અંદર 1 માઇનસ એક્સ સ્ક્વેર હોય ને, એના બદલે તમારે 1 માઇનસ સાઇન સ્ક્વેર થીટા હોત તો ઇઝીલી સિમ્પ્લિફાય થઈ જાત. ધેટ મીન્સ we need sin theta instead of x. So koi nahi, x is equal to sin theta le lo. Now differentiate both the sides, so you get dx is equal to cos theta dot d theta. Now modify our integration. In numerator we will get 1 plus sin square theta, and in denominator we will get under root of 1 minus sin square theta, and our dx will become cos theta dot d theta. Our theta is belongs to 0 to pi by 2. So here numerator will be as it is, and this under root of 1 minus sin square theta will become your cos theta. within the mode into cos theta will be as it is. Now, our theta is belongs to 0 to pi by 2. So, we don't have to worry about this mode. Cos theta will cancel out. We just have to integrate 1 plus sine square theta. To integrate sine square theta, we have to convert into 1 minus cos double the angle by 2 dot d theta. So, here we'll get 1 plus 1 by 2 is equal to 3 by 2 minus cos 2 theta upon 2 dot d theta. We are ready to integrate. Here integration of 3 by 2 will be 3 by 2 theta because we are integrating with respect to theta. In second term, 1 by 2 will be as it is. Integration of cos 2 theta will be sin 2 theta upon coefficient of theta, which is 2 plus c. But we need our answer in terms of x. So for that, we have to remember our assumption x is equal to sin theta. So we should convert this sin 2 theta into 2 sin theta cos theta. 1 by 2 upon 2 and minus 3 by 2 theta will be as it is. This 2 will cancel out. We need the value of cos theta. And for that, let's use triangle method. Suppose this is your theta. So opposite upon hypotenuse will be 1 and adjacent will be 1 minus x square. So we can get cos theta is equal to under root of 1 minus x square. Substitute the values. You will get 3 by 2 of theta is your sine inverse x minus 1 by 2 will be as it is. Sine theta will be x and cos theta will be under root of 1 minus x square plus c, which is given in option A. Ta-da! Here we have to integrate 1 upon under root of 1 minus x, or we can say whole raised to minus 1 by 2 of 1 minus x. So integration of box raised to minus 1 by 2 is simply box raised to minus 1 by 2 plus 1, or we can say 1 by 2 upon 1 by 2. But within the box we have 1 minus x. So we have to divide the coefficient of x, which is minus 1 plus c. So we can simplify this as minus 2 under root of 1 minus x plus c, which is given in option B. Ta-da! Here you have to integrate 1 upon e raised to x plus 1. Basically, e raised to x plus 1 is your inner function. So let's assume e raised to x plus 1 is equal to t. But we don't have differentiation of the function within the multiplication of dx. So in this situation, we have to make x subjective. So here we'll get x is equal to log of t minus 1. Now, if we differentiate both the sides, we will get dx is equal to 1 upon t minus 1 into 1 dot dt. So we are ready to modify our integration. This 1 upon e raised to x plus 1 will become your t, and your dx will become 1 upon t minus 1 dot dt. So here we get integration of 1 upon t into t minus 1 dot dt. Now here we have integration of 1 upon x minus a into x minus b form, where your b is greater than a, where your b is 1 and a is 0. So it can be directly integrated as 1 upon b minus a, or we can say 1 minus 0 log mod t minus b, which is 1 upon t minus a, which is 0 plus c. So here we'll get log mod instead of t. Let's substitute its value, which is e raised to x plus 1 minus 1 upon e raised to x plus 1 minus 0 plus c. So here 1 1 we cancel out and our answer will be log mod e raised to x upon e raised to x plus 1 plus c, which is given in option A. Ta-da! જો sec અને tan વાળા સમમાં શું ડીલ કરવાની એ હું તમને સમજાવું. In this question we have to integrate sec x into tan x raised to 3. Here your tan x is your inner function, પણ tan x નો differentiation sec square x available છે, તમે કહેશો યાર નહીં. શું કરીશું, tan x ને આપણે સ્પ્લિટ કરી નાખીએ. sec x into tan x into tan square x. Sec x tan x and a differentiation of sec x. So we should get function of sec x instead of tan square x. So we can convert into sec square x minus 1. And your sec x tan x will be as it is. Now we can assume sec x is equal to t and we will get sec x tan x dot dx is equal to dt. So here sec square x minus 1 will become your t square minus 1 and the sec x tan x dot dx will become your dt. So integration of t square will be t raised to 3 by 3 minus integration of 1 will be t plus c. If you get the final answer, just substitute the value of t, which is sec x whole cube by 3 minus sec x plus c, which is given in option A. Ta-da! Here we have to integrate 1 plus tan x upon x plus log mod sec x. As you can see, we have the differentiation of denominator into numerator. So let's assume our denominator, which is x plus log mod sec x, is your t. Differentiate both the side. Differentiation of x will be 1 and differentiation of log box will be 1 upon box into d by dx of box. Within the box we have sec x, so we just have to multiply differentiation of sec x, which is sec x into tan x whole dot dx is equal to dt. So here sec x will cancel out and we will get 1 plus tan x dot dx will become your dt. So we can easily modify our integration as this 1 plus tan x dot dx will become your dt and whole denominator is your t. So integration of 1 upon t is simply log mod t plus c. Substitute the value of t and we will get log mod x plus log sec x plus c, which is given in option A. Ta-da! Here we have to integrate 1 upon 1 plus sin square x, which is in the form of 1 upon a sin square x plus b cos square x plus c. So let's follow each step. Our first step is we have to divide numerator as well as denominator by cos square x. So in numerator 1 upon cos square x will become your sec square x and in denominator 1 upon cos square x will become sec square x and sin square x upon cos square x will become tan square x. Now we have to replace sec square x by tan square x plus 1. So let's say our numerator will be as it is and in denominator the sec square x is converted into 1 plus tan square x plus tan square x still remain as it is. This tan square x plus tan square x will become 2 tan square x. So we get the function of tan x in denominator and its differentiation within the multiplication of dx. So let's assume tan x is equal to t. Differentiation of tan x will be sec square x dot dx is equal to dt. So we can modify our integration as this sec square x dot dx will become your dt, and in denominator we will get 1 plus 2 times t square. Now before we go for integration, let's try to take the coefficient of t square common. So 1 by 2 is common. Integration of 1 upon t square plus 1 by 2 dot dt, which is in the form of x square plus a square. So our 1 by 2 will be as it is, and integration of 1 upon t square plus 1 by 2 will be 1 upon a, we can say 1 upon root 2 tan inverse of x upon a, you can say t upon 1 upon root 2 plus c. Now in simplification, we can say this root 2 will cancel out, we will get 1 upon root 2 tan inverse of root 2t. To get the final answer, we have to substitute the value of t, which is tan x plus c. So tada! This is your final answer, which is given in option A. Here you have to integrate sin 2x raised to 3 upon cos 2x raised to 5. If we simplify our denominator, then we can say cos 2x raised to 5 can be split into cos cube 2x into 1 upon cos square x dot dx. So this sin cube 2x upon cos cube 2x will become your tan cube 2x, and 1 upon cos square 2x will become your sec square 2x dot dx. So we get the differentiation of tan 2x within the multiplication of dx. So let's assume tan 2x is equal to t. Differentiate both the side, we will get sec square 2x into 2 dot dx is equal to dt. But we have only sec square 2x dot dx. So let's move this 2 on the right side. So we will get dt by 2. So let's modify. This times 2x cube will become your t cube, and sec square 2x dot dx will become your dt by 2. You don't have to worry about this 1 by 2. Integration of t cube will be t raised to 4 upon 4 plus c, or we can say 1 by 8 t raised to 4. Just substitute the value of t, which is tan 2x plus c. So tada! This is your final answer, which is given in option D. Here you have to integrate x square plus 4 upon x cube plus 6x square plus 5, which is polynomial upon polynomial. So we have to check the order of polynomial. In numerator we have second order polynomial, and in denominator we have third order polynomial. So we can say the order of denominator is greater than order of numerator. So in this case, we have to set the differentiation in terms of numerator. So let's check the differentiation of your denominator, which is x cube plus 6x square plus 5. Differentiation of x cube will be 3x square. Differentiation of 6x square will be 12x, and differentiation of 5 will be 0. So we need 3x square plus 12x, and for that we have to multiply and divide by 3. So we will get 3x square plus 4 3s are 12x upon the denominator will be as it is. So here we get fx and f dash x form, and its integration is quite easy. Log mode your denominator, which is x cube plus 6x square plus 5 plus c, which is given in option A. Ta-da!